Okay, in this video, I want to go over how to find the vertex, maximum minimum value, axis symmetry, domain, and range of all of these four quadratic equations. And the first two examples will be in vertex form, which is written right here. And the last two examples will be in standard form, which is written just right above that. And notice that lowercase abc, capital A, and lowercase hk are any real numbers, okay? So it doesn't matter what value they are, the way you do it is still the same. And for the standard form quadratic equations, there are two ways to do it. One way is to use this little special formula, negative b over 2a, to find the x-coordinate of the vertex, and then we go from there. Another way is by the technique of completing the square. So I have a videos for technique of completing a square, but in this case, I'm going to go ahead and write out the work. And because it's a little special due to the fact that you have a leading coefficient different than positive 1. So we'll get to that. But in example 1, we have negative 1 over 2 times y plus 4 equal to x minus 7 squared. Well, in vertex form, it is y equals something. But in this case, you got the product of negative 1/2 and y plus 4. So we have to get y by itself by first getting rid of negative 1/2 by multiplying both sides by negative 2. So negative 2 multiplied by negative 1 over 2 times y plus 4 equal to x minus 7 squared multiplied by negative 2. Negative times negative is going to be positive. The 2 cancel out. So we'll be left with just positive 1. But anything multiplied by positive 1 is just itself. So we got y plus 4 by itself equal negative 2 times x minus 7 square. So hey, we're almost there. All we have to do is that we have to get y by itself by subtracting 4 to both sides next. So we got y equal to negative 2 times x minus 7 square minus 4. So hey, it's already in the vertex form that we want. So what is the vertex of these equations? Now, if we compare our results to the vertex form, notice that our capital A is negative 2. The x-coordinate of the vertex, which is the h, is going to be positive 7. And the reason why it's positive 7 instead of negative 7 is because we have the minus sign that we are able to, that matches with what the general vertex form of quadratic equation says. So every time inside of parentheses you have minus a number, you know that the x-coordinate of the vertex is going to be positive. And for the y-coordinate of the vertex, which is denoted by plus k here, well, notice that you got minus 4. So if you just convert this into the plus form by rewriting it into plus negative 4, you can tell right away that the y-coordinate of the vertex is going to be negative 4. All right? So the vertex h comma k is going to be equals to positive 7 comma negative 4. Now, is it a maximum or actually no, not yet. Axis of symmetry, my bad. Well, to find the axis of symmetry, all you have to do is that you take the inside of the parentheses, x minus 7, set equal to 0, solve for x. So that means it is going to be x equal positive 7, which is the same as the x-coordinate of the vertex. And the axis of symmetry is what a function is going to have of each other's half. So one half is going to have the mirror image of the other. Now, is it going to be the maximum or the minimum? Well, let's graph the function out a little bit. So the vertex is 7 and negative 4, so maybe right here. Now, algebraically, because your function is multiplying by a negative number on the front, algebraically, you know for sure that your function is going to have a maximum. Well, why is that? Well, because graphically, when you graph out your function is going to open downward like this. So something like that. And because your function is opening downward, by always reading the graph or any graph from left to right, your function go from increasing to decreasing. Okay? And because of that, That's why you have the maximum value at y equal to -4, which is at the y coordinate of the vertex. And the reason why your function is opening downward instead of opening upward is because of the fact that you're transforming the function by reflecting it vertically across the x-axis. And you're reflecting it across the x-axis, or you're reflecting it vertically due to the fact that you're multiplying this function by the negative number on the front. So I have a video of where I go over different transformation of functions. So I'll link it in the description so you guys can check it out. But yeah, for any function, especially quadratic equations, if you multiply by a negative number on the front, you're talking about vertical reflection. So usually your graph, your quadratic function, your parent quadratic function, open upward like that, but because you're multiplying by a negative number on the front, is reflecting downward or reflecting vertically. But anyway, too much time on that. So yeah, we get a maximum at y equal -4. Now, what about the domain? Well, for the domain, let's see. Algebraically, if you look at your equations, you don't have any denominator. So you can take any x value from -infinity to +infinity, plug it into the function, and you will be able to crank out the corresponding y value. That means the corresponding y value of each x value actually exists. And it is actually equal to whatever the number is when you plug in that x value. So that means the domain is going to be from -infinity to +infinity. Now graphically, you just have to read the graph from left, the x value from left to right again, and try to see if there's any point of discontinuity on here. Well, algebraically, since we don't have any denominator, we don't have to worry about any point of discontinuity because the function, because all of the x values on this function will always have its corresponding y value. So that's why the domain is from -infinity to +infinity. Now, what about the range? Well, for the range, you have to read the y values from bottom to up. Well, if you read the y values of this function from bottom to up, you know your range is going to go from -infinity to the highest y value, which is y equal to -4. And because there's no point of discontinuity at y equal to -4, we have to put the bracket to include that y value in the range. And yeah, that's how we find vertex as symmetry, domain, range, and maximum or minimum of this example.